This is section 1-2, properties of real numbers. What we'll learn this time is to classify real numbers and use the properties of real numbers to evaluate expressions. So we're going to start down about halfway down the page on page 11. If we have real numbers are numbers we use in our life every day. They can be found on a number line, like -1, square root of 2, -2.5. These are all real numbers. And then underneath that, we can classify real numbers as rational or irrational. So let's look at rational first. So rational numbers are numbers that we can express as a ratio as m over n, where n cannot equal 0. And the decimal form of a rational number is either terminating or repeating, which means something like 1/6 for a fraction, that's a rational number. 1.9, that's terminating. There's nothing after that 9. It's just 1.9. Or repeating, which is 1.575757. That 57 keeps repeating on forever. So those are the rational numbers. Square root of 4 also. Now what is an irrational number? So an irrational number is a number that in decimal form neither terminates nor repeats. Doesn't terminate nor repeat. Like, for example, square root of 5. It just keeps going on and on and on and on. And it doesn't repeat. So let's look at a number that's non-repeating, pi. Pi equals 3.14 and so on, and it keeps going and it never repeats. Another example is a number such as 5.382679843 and so on and so on. It doesn't have a pattern. And again, and this one never terminates. It keeps going and going. So those are what irrational numbers are. So we have on the top of page 12 a Venn diagram. And it's a Venn diagram of all the real numbers and their subsets. So we have the rational and irrational. So in this diagram, the left side is more of a square section of this rectangle. Those are all our rational numbers. And if you notice on the left, there's circles inside of circles. Let's go to the very center circle. And that circle is labeled n. These are all of the natural numbers. So natural numbers are numbers such as 1, 2, 3, 4, 5, 6, and so on. Keep going up. Starting at 1, going up. So those are the natural numbers. Next, we're looking at the whole numbers, which is labeled with a W. Whole numbers are all of the natural numbers plus 0. So those would be 0, 1, 2, 3, 4, and so on. Those are our whole numbers. Okay, another layer out is labeled Z. And these are our integers. So these are a subset of the rational numbers that are the negative numbers included. So say -3, -2, -1, 0, 1, 2, 3, 4, and so on. So all of the natural numbers are included, all of the whole numbers are included, and now the integers add in all the negative numbers as well. Okay, so these are all of the subsets of our rational numbers, which on the Venn diagram is labeled as Q. So the integers, the whole numbers, and natural are all subsets of our rational numbers. And if you notice on the right side, we have the irrational numbers, which are the numbers that do not repeat and do not terminate. Okay. Now let's look at where square roots fall when we're looking at classifying numbers. If we have a square root such as the square root of 36, that square root is a whole number. The square root of 36 is 6. But if we were to look at a number like 35, the square root of that 35 is not a whole number. It falls somewhere between 5 and 6. So for a square root to be a rational number, it has to be a whole number. A whole number. But an irrational square root is a number that is not a whole number. It falls in between something, such as 35. It falls in between 5 and 6. So it's not a whole number. So that's how we classify square roots. Now let's look at example 1. Example 1, classifying numbers. Part A says, it says to name the sets of numbers to which each number belongs. Square root of 16. What is the square root of 16? Square root of 16 is 4. Let's look at our Venn diagram. The very center is a natural number. 1, 2, 3, 4, 5, and so on. Yes, 4 falls in there, so we can say it's a natural number. So we label it as N for natural. Now let's go one ring out on our Venn diagram. It says the whole numbers. 0, 1, 2, 3, 4. Yes, it falls in there as well. Integers is the next ring out, which also, integers have the whole and the natural. So yes, it does fall into the integers, which is labeled as Z. Okay, and since it falls under these subsets, it is a rational number, so we can call it Q. It's labeled Q for rational. And it falls in all these subsets, so we know it is a real number. So, the square root of 16, which is 4, can be classified as a natural, a whole, an integer, a rational, and a real number. Part B, middle of page 12, negative 185. Let's go up the chain. Is it a whole, is it a natural number? No, it's not. It's negative 185. Let's look at B, our next ring, which is a whole number. 0, 1, 2, 3, 4, 5. Doesn't fall there either. Z, it's an integer. Yes, it's an integer. It can be written as n over 1, but it's a negative number, so we can start with it being an integer. So, an integer falls under rationals. So we say it's an integer, which I'm labeling as Z, and then I'm labeling it as Q because it's a rational number, and an R because it is a real number. So negative 185 is an integer, it's a rational, and it's a real number. Part C, square root of 20. Okay, square root of 20 is an irrational number because it falls, remember the rules, if the square root is a whole number, it's rational. If it falls in between two numbers, it's irrational because it falls somewhere in between 4 and 5. So it's an irrational number, and the Venn diagram, the whole right section was irrational. So it's irrational and it's a real number. Example D, negative 7/8. Okay, it's a negative number, so we know it can't be natural, we know it cannot be whole, but it's a fraction, so can it be an integer? No, it cannot. It cannot be written as n over 1. So we go up to the next level, which is rational. So we can say negative 7/8 is rational and it's real. The last one, part E, is 0.45 with a bar over our 4/5. What that means is 0.45 repeating forever. So we can say 0.45, 45, 45, 45, and so on. And if we remember the rules of our decimals, if a number is repeating or it terminates, then it's rational. If it does not repeat and does not terminate, it's irrational. So this one is a rational number because it's repeating. So we can say this one is Q for rational and R for real number. So we can classify this as a rational number and a real number. Okay, so now let's look at the bottom of page 12. It's our key concepts. So what this means is that we have a box, and we're going to talk more about the properties of real numbers. The real number system is an example of a mathematical structure called a field. Some of the properties of a field are summarized in this table. So we have any real numbers A, B, and C. We have 5 different properties. So we have commutative. We have a commutative property. We have the associative property. We have the identity. We have the inverse. And we have the distributive. Okay, so we have these 5 properties, and they're in the table. So commutative, we can say A plus B equals B plus A, because it does not matter what order you add it. Associative, that's for addition. We also have multiplication. So we have 2 ways to do this. We have addition, and then we have multiplication. So commutative, A plus B equals B plus A. For commutative for multiplication, A times B equals B times A. Now, the associative property, we have, in parentheses, A plus B, close parentheses, plus C. We can rearrange this any way we want. We can say A plus open B plus C, close parentheses. Same thing for multiplication. We can say A times B in parentheses times C equals A open B times C close, then that's the same thing. Identity. A plus 0 equals A equals 0 plus A. So whether it's 0 plus A or A plus 0, it's always going to equal A. And for multiplication, A times 1 equals A equals 1 times A. So any number times 1 equals the number. Inverse. A plus open negative A close equals 0. And we do the same thing. Equals open negative A plus A also equals 0. And in multiplication, the inverse is a little different. If A cannot equal 0, so we can say A times 1 over A equals 1, which also equals 1 over A times A. Because if you remember, A over 1, and we multiply across, A times 1 is A over 1 times A. So A over A, when you simplify, is 1. Distributive. So the distributive property, we have A open, B plus C close equals AB plus AC. And if we have B open, or B open parentheses B plus C close, A equals BA plus CA. Because when you're distributing, you need to make sure that what you're multiplying on the outside gets distributed to every single piece on the inside. So those are all the properties in a nutshell. Now let's go to the top of page 13. Example 2, identify properties of real numbers. So now we're going to do properties. Part A says name the property illustrated by each equation. We have A, so we have open 5 plus 7 close plus 8 equals 8 plus 5, open 5 plus 7. Doesn't matter which order. So because the commutative property says that the order in which you add does not matter or change the sum. Part B, the associative property of multiplication. 3 open 4x closed equals open 3 times 4 closed times x. You're going to get the same thing. You're going to get 12x, because 3 times 4x is 12x, 3 times 4 is 12, times x is 12x. That's the associative property of multiplication. First one was commutative. Second one is associative. So multiplication, commutative property of addition. Okay, example 3. Now let's look at example 3. Example 3 says identify the additive inverse and multiplicative inverse for each number. So, part A says negative 1 and 3/4. Starting with the additive inverse. What do we need to add to this to make it equal 0? Well, if we have negative 1 and 3/4, we need to add a positive 1 and 3/4, because that will bring us up to 0 on the number line. So plus 1 and 3/4 will equal 0. So the additive inverse is 1 and 3/4. So that's the additive inverse. Okay. Now, what about the multiplicative inverse? So if we have negative 1 and 3/4, let's turn that into an improper fraction. Take our denominator 4, times it by our whole number, add the numerator. So we get negative 7/4. So the additive, or the multiplicative inverse would be what we need to multiply it out to be to equal 1. So our numerator has to be the same as the denominator. So we flip this over and make our numerator our denominator our numerator, and that's our inverse. So if we were to multiply negative 7/4 by negative 4/7, we want it to be a positive, so we keep that negative on both of them. What we get is 1, because if we look at our numerators, negative 7 times 4 is times negative 4 is 28 over 28. 28 over 28 equals 1. So our multiplicative inverse is negative 4/7. Multiplicative inverse. Okay, let's look at the second example here. I'll make myself some more space on my whiteboard. Again, we're on page 13, halfway down. So we have 1.25. So what do we need to add to that for our additive inverse to get up to 0? If it's at 1.25, we need to add negative 1.25. So we have 1.25 plus, open parentheses, negative 1.25, close parentheses. That'll take us up to 0, or down to 0. So the additive inverse is negative 1.25. Okay, now we need the multiplicative. And we're doing this still in fraction form, even though we have a decimal. What do we need to multiply 1.25 to bring it to 1? So remember, we flip it over, make our numerator, denominator, numerator, multiply it together, and that'll give us our multiplicative inverse. So we have 1.25. We multiply that by 1 over 1.25. It's okay that there's a decimal in a fraction. It's all right. Then we multiply across 1.25 times 1, 1.25, the denominator of 1.25. So 1.25 over 1.25, and when we reduce, that equals 1. So we can say our multiplicative inverse is 1 over 1.25 for our multiplicative inverse. So that is example 3 on page 13. So please turn your book now to page 14. Page 14 is very tough, but now we're going to talk about the distributive property. Okay, so this one is a word problem. We're talking about food service this time. It says a restaurant adds 20% tip So they add 20% tip to the bills of parties of 6 or more people. So 6 plus people get a 20% gratuity added onto it. Suppose a server waits on 5 such tables. So 5 tables of over 6 people. The bill without the tip for each party is listed in the table. How much did the server make in tips during this shift? Okay, so we have a table, and we have 185.45 is the first party. We have a total of 205.20. We have 195.05. So 185.45. 205.20, 195.05, 245.80, and the last is 262. So those are our 5 different bills that these people had to pay. Okay, so there's 2 different methods to find this. Look at the first method, which is in your textbook on page 14. Multiply each dollar amount by 20% or 0.2 and then add. So what it's saying is you take, so total would equal 185.45 times 0.2 plus, open parentheses, 205.20, close parentheses, times 0.2 plus, open parentheses, 195.05, close parentheses, 0 times 0.2, plus, open 245.80, close, times 0.2, plus, open 262, close, times 0.2. So you do all that multiplication, what you get is, then you have to add all of those totals you get. So if you get 185.45 times 0.2, you get 37.09 plus 41.04 plus 39.16 plus 52.40. So then you add those all up and you end up with $218.70, which is the amount of tip that this server makes. The second way that you can actually do this is by adding up everything inside of the parentheses and then multiplying it by 0.2. So what you end up with is 0.2, open parentheses, 185.45 plus 205.20 plus 195.05 plus 245.80 plus 262. So you add those all up and then distribute that 0.2. So when we add them up, we get 0.2, open parentheses, 1,093.50. And then you multiply it by 0.2. And you get the same answer, $218.70. So it's the same answer. Both methods will result in getting the correct answer. You can do it either way. All right, let's look at the last example of this section. This is simplified. So this is example 5. We're on page 14 still, 2/3 of the way down the page. So this time we're going to simplify an expression. What we have is the expression. It says simplify to open 5m plus n, close parentheses, plus 3 open parentheses 2m minus 4n close parentheses. So remember, when we want to use the distributive property, we need to multiply everything through the entire expression, what's inside of this parentheses. So what does that mean? Well, we can do it this way. So we can first multiply 2 times 5m. We'll get 2 open 5m close plus 2 times our n, 2n. So we've done that first part. So remember, in order of operations, we do multiplication first. Well, it's inside the parentheses, but we're distributing, which is a specific property. Now let's move to the next part. We have plus 3 open 2m minus 4n. So let's distribute this 3. It's a plus 3. So we have 2 open 5m close plus 2n plus 3 open 2m close minus, we have 3 minus 3 times 4n close. Okay, then we need to use just multiply and get rid of all of our parentheses. So we have working left to right. 2 times 5n. 10m plus 2n plus 3 open 2m. So that's multiplication. Plus 6m minus, because we have negative 3 times positive 4n minus 12n. Using our commutative property, we're going to rearrange these in the right order so we can add like terms. So let's arrange this so that we can have all of our m's together and our n's together. So like we have a 10m and we have a 6m. So let's write it as this. 10m plus 6m, and now we have our n still to deal with, plus 2n minus 12n. Okay, but this time, instead of just adding this, we're going to use the distributive property. So we have a 10m plus a 6m, and we can kind of pull this apart. So we'll look at this like this. We'll have open parentheses 10 plus 6 close parentheses with an m on the outside. Because we have to add our numbers together and then multiply by our n. So now we have open 10 plus 6 close times n. And then we have a 2n minus 12n. Again, those are both n's, so we can pull that n out and multiply it after we're done using the distributive property. So then we get plus open 2 minus 12 close times our n. And then we can simplify. Starting on the left, open 10 plus 6 close, that's 16 times n gives us 16m. And then inside the parentheses on the second term, we have plus open 2 minus 12 close times n. 2 minus 12 gives us negative 10 times n, so minus 10n. And that's as far as we can go, and that is our answer. If you have any confusion, please go back and re-listen to the whole thing or parts where you need help.